Hello, let's talk about solving systems of equations. Solving a system of equations by graphing is one of the three ways that you're going to be learning how to solve a system. Now you're probably wondering what a system is. You may notice that we have a couple of equations here. A system of equations is when you have more than one equation using more than one variable. So we have two equations here, and everything that we're going to be doing for our purposes will be two equations with two variables, most likely x and y. When we solve them, we are looking for a solution. Now the solution to the system is an ordered pair that works in both equations. An ordered pair that works in both equations. Now you'll have to forgive me, my handwriting on this. I'm working on my tablet, and this is not the easiest thing for me to write on. So you'll have to forgive my handwriting. It's a little on the messy side. Okay, so a solution to a system is an ordered pair that works in both equations. Okay, given that, if I want to ask you if an ordered pair is a solution, for example, this first problem right here, I want to know if 5, 2 is a solution to the following system. If it's a solution to the system, it must work in both equations. So what I'm going to do is I'm going to check it. And to check anything in algebra, all we do is ESA, we plug it in. So 5 is my x value, so I have 3 times 5 minus 2 times my y value, which is 2, equals 11. So 15 minus 4 equals 11, and that is true. 11 does equal 11. So what that means is 5, 2 is a point that's on that line, which means it's a solution for that equation. Now let's try the next one. Negative 5 plus 6 times 2 equals 7. So negative 5 plus 12 is 7. And yes, 7 does equal 7. Yes, it is a solution. So if it's a solution to the system, it must work in both. Okay, let's try another one. Let's decide whether this ordered pair is a solution to the system. Again, to do this, we're going to plug it in. That's my x value, that's my y value. So 3 plus 3 times negative 6 equals 15. 3 minus 18 equals 15. Uh-oh, running into a problem here. Negative 15 equals 15. I don't think so. Those are not equal. No, this is not a solution. Not a solution. Now you'll notice that I didn't even try the second equation, because to be a solution to the system, it must work in both. So to review, a solution to a system is an ordered pair that works in both equations. If you want to know if something's a solution, you need to check it in both equations. Now, if a solution is an equation that works in both, or is an ordered pair that works in both, one of the things we can do is graph all the ordered pairs that work in this equation, and graph all the ordered pairs that work in this equation. The solution is going to be the point that they have in common, the one point that works in both equations. Okay, so let's graph this first one. Your slope is going to be 2 over 1, which means up 2, forwards 1. Your y-intercept, since I don't see 1, is going to be 0. So you're going to put a dot at 0, and then you're going to go up 2 over 1. And I like to make lots of dots. I like to go down and back, because we don't know where this is going to cross. Okay, so I should have the ability here to make my line. Well, that didn't work out like I was hoping it would. Let me erase that. And I'll go back. Let me get this fixed. Okay, so we have this fixed. Now, I've never asked you to do this before, and that's because I've only ever had you graph one equation on one coordinate grid. But anytime I'm asking you to do more than one equation on a coordinate grid, you need to label. And by region standard, you have to have them labeled. For more than one, you have to have them labeled. Okay, so let's try this next one. Your slope would be 3, which is 3 over 1, which means up 3, forwards 1. And your y-intercept is -3. So I'm going to put a dot at -3, and then I'm going to go up 3 and over 1. I'm going to make lots of dots until I overlap one of them. So 1, 2, 3, over 1. Put another dot. Up 3, 1, 2, 3, over 1. I'm getting close. Up 3, 1, 2, 3, over 1. There's my solution right there. Okay. So I'll make my next line here. Of course, we want to label it. This is y is equal to 3x minus 3. And the one thing you definitely want to make sure is you want to do your solution. You want to state it. Two ways you can state it. You could write it as an ordered pair. So this would be the ordered pair of 3, 6. You could also write it if you wanted to write it as x equals 3, y equals 6. It doesn't matter to me. And the nice part is if you wanted to make sure you were correct, you could do a quick check. And to do a check, we just do ESA. So in other words, y equals 2x. My y value is 6, so 6 is equal to 2 times 3. And that is true. So it definitely works in that equation. Let's try this next one. 6 is equal to 3 times 3 minus 3. So 6 is equal to 9 minus 3. And that is, whoops. And that is also true. So it works in both. All right, let's try another one. Okay, find a solution to the system by graphing. Okay, this is good. We can graph this, not a problem. My slope is -2 over 1. Now that's going to mean down 2 and forwards 1. And your y-intercept is 3. So let's put a dot at 3. And now we're going to go down 2, forwards 1. Down 2, forwards 1. Down 2, forwards 1. And if you want to do a few where you go up and back, you can do that. Okay, now we're going to make the line. And of course, as I said, if we are going to put more than one equation on here, then we need to label it. So -2x plus 3. Okay, let's graph our next one. Our slope is 1/2, which means up 1, forwards 2. My y-intercept is also 3. So when I go to graph this, I notice the y-intercepts are the same for both. So up 1, forwards 2, up 1, forwards 2, up 1, forwards 2. I'm wondering if any of you noticed that the slopes are negative reciprocals. And I'm hoping you remember if the slopes are negative reciprocals, then we know that these two lines that we're drawing here cross at a 90-degree angle. They are perpendicular. So I'm going to label this 1/2 x plus 3. But again, you got to make sure you write your solution in. That's important. I once had a student on a Regents exam do a beautiful job graphing, but the student forgot to actually write the solution. And therefore did not get full credit, and it was the only question that she missed on her Regents exam. So don't let that be you. All right, so x is equal to 0 or y is equal to 3. Either way, if you want to write it as an ordered pair or if you want to write it separately like this, you can. Okay, and if you want to do a quick mental check just to make sure that this is correct, you can do that. I'm going to do it in green here. So that would be 3 is equal to -2 times 0 plus 3. That's 3 equals 3. Yeah, that works. So now I have 3 is equal to half of 0 plus 3, which means 3 is equal to 3. It checks. So I know I have this right. Now let's try one last one, and then you can practice some on your own. Okay, what's different about this one is that these should both be written in y equals mx plus b. When they're written like this, then it's easy to graph them. So in order to rewrite them, I'm going to move my x over. So I end up with y is equal to negative x plus a negative 8. Or if you just want to say negative x minus 8, same thing. So your slope is negative 1 over 1, which means down 1, forwards 1. Your y-intercept is negative 8. So let's see, I'm going to have to move this a little bit. So y-intercept is negative 8, down 1, forwards 1, down 1, forwards 1. Clearly, I'm running out of space, so I think I'm going to have to go up and back. And of course, as I mentioned before, you have to make sure that you label. And I get a lot of kids that will ask me, which one do you label it with? And it doesn't matter. The original equation or the one that you rewrote, it doesn't matter. Choose which one you like better. All right, this next one's going to be a little bit more difficult. So let's minus a 2x from both sides. And I end up with negative y is equal to negative 2x minus 4. Divide both sides by negative 1. And I end up getting y is equal to positive 2x plus 4. So that means my slope is 2 over 1, which means, don't know where that came from. Whoops. Please hold. Let's fix that. Which means that we are going up 2, forwards 1, and your y-intercept is 4. Okay, so I'm going to put a dot at 4. Now if I go up and over, that doesn't really help me get to my solution. So I think I have to go the other way, which is down and back, down and back, down and back, down and back. There it is. And I'm just going to make a few more dots because for me, with how I have to make my lines, it's nice for me to be able to go from corner to corner. And when you do draw these, you really should fill the graph. No short, stubby lines. Fill the graph. All right, so final answer. Your solution, if we did this correctly, it looks like negative 4, negative 4. Okay, if I want to do a quick check, let's see, negative 4 plus negative 4. Yep, that's negative 8. That works for me. 2 times negative 4 minus a negative 4 equals negative 4. Well, let's see, that would be negative 8 minus a minus is plus a plus. So negative 8 plus 4 equals negative 4. Yeah, that's true. So it works. I know I have the correct answer. So now let's talk about independent practice. I would like you to go to your orange textbook that you should have at home, and I'd like you to do page 405. You're going to need a piece of graph paper, and I want you to do 3 through 27, but I only want you to do the multiples of 3. And what that means is you're going to do 3, 6, 9, 12, 15, 18, 21, 24, and 27. You're just going to do those. If you need more information on how to do this, then read the pages that precede that in the textbook. They explain to you and show you a few more examples. Good luck. Email me if you have any questions. Thank you.